What we're going to study today is this logistic growth, and we're looking at a day 2 set of notes. So the previous day's worth of notes for logistics was we studied how we could use the derivative for logistic growth and the differential equation for logistic growth to evaluate things like when is the function going to increase the most, how we get the concavity of the functions, things of that nature. What we're going to look at today is solving a logistic growth equation. Now, I'm going to preface this with this is well outside of the scope of what we need to be able to do in class. This is something that's useful, being able to see the algebra, but it is outside of what we need. There's a lot of good stuff in it, but it takes way too long, and they can't put it on a calculator section and expect you to do it because there are calculators, the TI-89, the TI Inspire, the HP Prime, that would all return a function. So to ask you to do this by hand is going to be impressive, to say the least. With that said, one of the things that we're interested in is how on earth would you solve this if we had to. So you can see that we've got dp dt is equal to 0.001 p 3000 times the quantity 3000 minus p. And our goal is to simply find the solution, the specific solution when p of 0 is 50. I look and I realize that this is separable. So I can rewrite this function as dp over p times 3000 minus p, which will equal that's going to be 1/1000th dt. I look at the problem and I recognize this as we integrate this. I recognize this as a partial fraction decomposition. So I can rewrite this left side as a over p plus b over 3000 minus p dp is equal to, and I will take the antiderivative of this side just so that it is done 1000 t plus c, and I'm just going to leave that side as it stands. So this becomes our 3000 minus p times a plus bp is equal to 1 from here. And we can solve this and find out that a is going to be 1 over 3000, which also happens to be the b term. So when I look at this, I can rewrite this left side as 1/3000th of the integral of 1 over p plus 1 over 3000 minus p dp is equal to the same thing on this side. I'm going to go ahead, I'm going to multiply the 3000 across to the 1000 t plus c and take the antiderivative of 1 over p plus 3000 minus p to get natural log the absolute value of p, minus, from u substitution, the natural log of 3000 minus p, and that will equal 3t plus c. And I will finally, at this point, get to natural log of p over 3000 minus p equals 3t plus c. The calculus actually stops right here, and I could see possibly maybe having to get to this point. At this stage, we would want to be able to get the equation in terms of p in terms of t. So we just want p equals, and this is where the problem gets mucky at best. So first thing, I see an e function, so I see this raise everything to the e. P over 3000 minus p is equal to ce to the 3t. And here we go. I need to get p by itself. And right here, it's really hard to look and see how that p actually happens. How on earth do we get the p by itself? Because I got two p's, and how do I get them combined? Well, the trick is actually going to be in kind of cross-multiplying this out. So if I do that, I wind up with a 3,000 minus p. And I'm going to take this p and multiply it down and call this 1 over ce to the 3t. So essentially what I did is I took the reciprocal of each one of these terms. And while it doesn't look like I did much here, what I actually can do is I can rewrite this left side as 3,000 minus p, 3,000 over p minus 1, because this can become p over p, equals 1 over ce to the 3t. I'm going to go ahead. I'm going to move this down just a little bit more. I'm going to wind up needing more space here in just a second. This is 3,000 over p is 1 over ce to the 3t plus 1, which I'm actually going to change as well and make a common denominator here of ce to the 3t and call this 1 plus ce to the 3t over ce to the 3t. And the reason why I did that is that the p in the denominator is useless to me. I'm going to take the reciprocal one more time and call this p over 3,000 is equal to ce to the 3t over 1 plus ce to the 3t. And as you can guess, I would multiply this by 3,000 at this stage to give me, keep it going, my final p is equal to 3,000 ce to the 3t over 1 plus ce to the 3t. So you can see that that was a lot. And what's worse is that we're not done. Because we now have to say evaluate p, which will be equal to 50 when t is 0. So we get 50, 3,000 c times 1 over 1 plus c. Oh boy. So as you can guess, this becomes 50 plus 50c, multiplied that 1 plus c over, equals 3,000 c this becomes 50 equals, oops, 2,950 c. And when I divide 50 over 2,950, which is really 5 over 295, which turns out to be 1 over 59, which is now my c. So now I know that p apparently is going to be, in this case, 3,000 over 59 e to the 3t over 1 plus e to the 3t over 59. To make matters even more enjoyable then, because that's not enough, this was typically not how you'll actually see the problem presented. You'll actually see this work right here be done, and we'll do even more to it from here, where we will say that this is actually p equals 3,000 e to the 3t over 59, and then we'll create a common denominator in our bottom, calling this 59 plus e to the 3t over 59, which is the same thing as 3,000 e to the 3t over 59 times 59 over 59 plus e to the 3t, giving us a final value of 3,000 e to the 3t over 59 plus e to the 3t. Like I said, it's about 10 minutes worth of work if you know what you're doing. You can imagine if you did not know what you were doing on that question, it would take a fairly significant amount of time. This is why this is something that I could anticipate. If this were a college exam, I could see this being one of the 3-question tests that they may possibly give you. I could also see this being something that is assigned to you as a homework problem that they would ask you to be able to solve on your own, giving you very little information other than teaching you how to do a separable differential equation and having you figure out the rest of the work to get from A to, Q at this point. The other 2 problems are not bad. They're all calculator questions at this point. Part B, asking you to substitute in the value of 2 for t. And part C, asking you to set the function equal to 2,400 and evaluating what that t might be when you solve. Both of those would be situations where I would never, ever want to solve that with anything but a calculator. I would never ask you to do anything of the sort at that point. And again, like I said, this is extraneous, this is extra stuff, not necessarily required to pass the AP test, but something that's worth looking at. I hope that it gives you at least something to look at, and I hope that kind of gives you an idea of what you need to do for these questions. I appreciate you taking the time to watch this, and I hope that it at least gave you some insights on the type of algebra that might be required as you go into upper level maths. I'll go again for the AP test a little bit outside of the scope of the time and expectation of that class. Thank you, and have a wonderful day.